Human engineering has come a long way, and the question of how tall we can build structures involves a mix of technology, materials science, and architectural creativity. As of now, the tallest building in the world is the Burj Khalifa in Dubai. Which stands at a staggering 828 meters, 2,717 feet. However, with advancements in materials like carbon, nanotubes, and innovative design concepts, future skyscrapers could surpass this height significantly. The limits of how tall we can build are influenced by factors such as the strength of construction materials, the stability of the building's foundation, and the engineering challenges of designing for extreme heights. Additionally, as buildings get taller, issues like wind forces, elevator systems, and the well-being of occupants become more complex. Looking ahead, projects like the Jeddah Tower in Saudi Arabia aim to reach over 1,000 meters, 3,280 feet, and speculative designs envision even taller structures, potentially reaching several kilometers into the sky. As technology and engineering continue to evolve, we may very well see buildings that challenge our current understanding of what's possible. Height and floors: the building reaches 828 meters, with 163 floors above ground and 2 additional floors below ground. Its spire adds to its height, and it also features a large observation deck on the 148th floor. The tiered design not only provides a visually striking appearance, but also helps manage wind loads and ensure stability. Each tier is slightly set back from the one below, giving the building its distinctive tapering profile. Environmental considerations: the building incorporates energy-efficient systems, including a sophisticated cooling system that uses chilled water to cool the interior. Its exterior is designed to withstand the extreme temperatures of the Dubai climate. Green Building certification: while not officially LEED certified, the Burj Khalifa was designed with sustainability in mind and incorporates several green building principles to lessen its environmental impact. The reflective glazing and landscaping contribute to reducing heat absorption. These environmental considerations reflect a growing awareness and commitment to sustainable practices in high-rise construction. The Burj Khalifa stands as an example of integrating advanced technology and design to address both functional and environmental challenges. The Burj Khalifa is the tallest building in the world, standing at 828 meters, 2,717 feet. While the Shanghai Tower is slightly shorter at 632 meters, 2,073 feet, the Burj Khalifa's height and number of floors make it the larger structure in terms of overall size and prominence. The potential limits to how tall humans can build structures are influenced by a combination of engineering, materials science, economics, and environmental factors. Here are some key considerations that set practical and theoretical limits on the height of buildings. Structural engineering limits: material strength. The height of a building is closely linked to the strength of the materials used. Current materials like steel and reinforced concrete have limitations. Innovations such as carbon, nanotubes, or graphene could push these boundaries, but they are not yet widely used in large-scale construction.
Structural load: as buildings get taller, the load on the lower floors increases significantly. Engineers need to design structures that can handle this immense pressure without collapsing or bending. Material science. Future materials. Emerging materials like ultra-strong carbon fiber or self-healing concrete may offer solutions to some of the challenges associated with extreme heights. Economic factors. Cost. The cost of building taller structures rises exponentially with height. This includes costs for materials, labor, and technology. The economic feasibility of such projects is a significant constraint. Return on investment. For extremely tall buildings to be viable, they need to offer substantial economic benefits, such as high-value commercial or residential space, which can be challenging to achieve at extreme heights. Environmental and practical considerations. Energy consumption. Tall buildings require substantial energy for heating, cooling, and ventilation. As height increases, so does the demand for energy-efficient systems. Vertical transportation. The logistics of moving people and goods up and down extremely tall structures become increasingly complex. Innovations in elevator technology and transportation systems are essential. Environmental impact. Tall buildings can affect local climate, wind patterns, and ecosystems. Managing these impacts is crucial for sustainable development. Theoretical limits. Earth's atmosphere. At extreme heights, the atmosphere becomes thin, affecting factors like air pressure and temperature. These changes can have implications for both construction and human habitation. Material strength. The strength and stability of materials like steel, concrete, and composites play a vital role. New materials with higher strength-to-weight ratios are necessary for very tall structures. Foundation design. The foundation must be robust enough to support the immense weight of the building. This often requires deep foundations or the use of advanced soil stabilization techniques. Materials and construction technology. Material properties. Current materials have limits in terms of their ability to withstand the stresses and strains of extreme heights. Innovations in materials science, such as ultra-strong composites or carbon nanotubes, could extend these limits. Construction techniques. Building taller structures requires advanced construction methods, such as high-altitude cranes, modular construction, and precise engineering techniques. The question of how tall humans can build touches on the boundaries of our engineering capabilities and architectural ambitions. As we've seen with towering structures like the Burj Khalifa and Shanghai Tower, we are continuously pushing these boundaries. The current tallest buildings exemplify the incredible advancements in technology and materials, but they also pose significant challenges. Future possibilities. Material innovation. Advances in materials, such as ultra-strong concrete and carbon nanotubes, are crucial for enabling taller structures. These materials provide the strength and flexibility needed to support greater heights. Engineering techniques. Innovations in engineering, including more sophisticated structural systems and wind management strategies, are helping overcome the challenges associated with extreme heights.